ang buhaton na to nini, no? We have to measure the distance of the structure to the nearest seismic fault. So, imo ra nang i-scale, no? Kay may mga mapa nga scale, panalitan nakakasmaktan imo na sukto dito pila na ka kilometers. Kamo na ano siguro mo idea unsa naka kuha ng kilometers, no? So pwede nimo na if you think that it is already beyond 15 kilometers, then wala tayong problema, no? So nga to dire natay table. Nalagyan na ba katong table o wala pa? Ano lang tanaw?
Wala ko dyan.
Yan, no? So, dire ang table 208-5, the 6, the 7, the 8, which gives you the value for the near source factor. So, ang near source factor nga kuan mag-agad siya sa seismic source type o mag-agad sa ilang distance, no? Of the structure from the nearest nga seismic fault. So, for example, if within 2 kilometer radius, 1.5 ang ilang factor. Between 2 to 5, so 1.2 is greater than 10 kilometers, so 1.0. Okay. And I think in between linear interpolation is permitted, no? So if, for example, you have between 5 and 10, 8 kilometers, then you can interpolate between 1.2 and 1. Then that is for the acceleration coefficient. This one is for the velocity coefficient. So na-diri gyapon, no? Depende sa source type. So, suppose your seismic source type is A, then it is located at a distance beyond 15 kilometers, then you have 1.0, no? If within the 10 kilometer radius, so 1.2. No? So muna siya atong ibasihan ining atong NA ug NV. Now for CA and CV, so kanisang table 28-7 and 28-8. So ang parameters nga mo determine, no, sa imong seismic coefficient CA are the soil profile type and the seismic zone. So mo ni siya mga values sa zone 2, gani sa zone 4. So ang ato kuan man ta, di ba? Kanang unsay atong soil profile SD unya zone 4, so that is 0.44 of NA. So monitoring atong gigamit, no? Then for CV, so zone 4, then SC, so SDA, so 0.64 NV. So that is the value that we used here. Then for the structural system factor, so this tends to weigh in the capability of the framing system to dissipate the seismic forces, no? So the more ductile a structure, the higher the value for R. If it is very stiff or very rigid, then R will have a lower value, no? So mo nang sa building dili sa maayo nga stiff kay mong building kay mo absorb na siya dako nga seismic force, no? Naglado na siya ay certain amount of ductility. So to determine the structural system factor, we consider a table there, no, for yung taas-taas ni siya nga table. Okay, so magsugod ta siguro na ini. So table 28-11A. So in this table, in the first column you have here the basic seismic force resisting system. Then it is being described, no? Then you have here the value of R and the limit, no, of the height under zone 2 and zone 4. So among the different types of seismic force system, we have the bearing wall system, the building frame system. But in our case, we have the moment resisting frame system, no? So the moment resisting frame is composed of columns and girders. So the lateral stiffness of the building is provided by frame action, no? The bending stiffness of the column and the girders. So naata diri mo tanaw moment resisting frame system. And we use kining special reinforced concrete moment frame, or in usually abbreviated SMRF, no, special moment resisting frame, where R is 8.5, no, and zone 2 no limit, and zone 4 no limit as to the height of the building. So intermediate reinforced concrete moment frame and ordinary reinforced concrete moment frame are not permitted within zone 4. No? So when NP not permitted, NL no limit. So mapugos ta kay kita naman ta sa zone 4, then we are forced to use this type of moment frame. No? Kung nakaka sa Palawan, pwede ra, no? Pwede ka mo gamit ng intermediate or ordinary, no? Okay, so nga na to gikuha ang value nga R nga equal to 8.5. The next for the frame material factor, so gikuha dyan natin yung frame material factor. I hope na sa unahan o apaka na ito tumalagi. Murag na labyan siguro. Ato lang pa na yun sa unahan.